Hello, folks. This is Kent Hovind in Lenox, Alabama, and it is May the 23rd, 2017. And I have a college student on the phone who called with some questions, some things he's being taught in school. Do you care to give your name there, sir? Or at least your first name?
My name is Jackson Wheat.
Jackson, okay.
And I'm from Shreveport.
And you are in school, and are they teaching you evolution?
Yes, sir. The evolution is the class evolution is a junior course. We get an introduction to it in the second semester of freshman year.
Okay. Well, thank you, Jackson, for letting me record this for our YouTube listeners, and maybe it'll help some other people. You had some very interesting, perfectly fair questions. I hate to make you do this, but would you like to start over which questions you had, and I'll be able to give my answer to them.
Okay, that's perfectly fine. So I think we both agree that natural selection happens and that it only selects from the existing genetic pool and doesn't add itself any genetic material.
Correct. Yeah, on my video number 4 of my seminar series, I talk about that. Natural selection simply selects. Suppose you decided you want to create a population of people 30 feet tall. So you're going to kill everybody. Right. You're going to kill everybody under 30 feet tall, which would be everybody, and you now have wiped out humanity. And you can't create a population of people 30 feet tall because there aren't any 30-footers to select from. However, if you wanted to create a population of people that are 7 feet tall or more, you probably could do that. Go around the world, find all the 7-footers, and everybody else, you kill them, and let those 7-footers breed. And out of their children, a large percentage may be over 7 feet, and so then you kill those under 7. You do that 3 or 4 or 5 generations in a row, and you now have a population of 7-footers. This is what farmers do with their cows or their corn or their soybeans or anything. They select a particular trait that they want, and they select it out of the population. But as you mentioned, and as I mentioned to you on our previous call, they're not creating anything. They're only selecting a slice of existing gene code. So natural selection proves creation. I think it proves that the Creator designed his creatures with the ability to produce a wide range of offspring, so some will survive in any given environment. Anyway, so go ahead.
Okay, so I like the analogy of what farmers use, so I'll go with that one. So we look at corn, for instance. Natural corn is teosint, right?
Uh-huh.
It's small. It's very hard. It's not very edible. Well, I mean, to some people it might be edible, but to me it's not.
Right.
But the farmers grew our modern commercialized corn ultimately from teosint, but they didn't grow the corn simply through natural selection alone, because there were no teosint that are like our commercialized corn. So they had to capitalize on mutations as well as natural or as artificial selection in that case to produce the modern variations of corn that we have in commercialized business.
Correct.
So for artificial selection, whether it's corn or bananas or strawberries or what have you, it's a matter of capitalizing on not just the selection process, but also the mutation.
Correct.
That add something, maybe a little bit of size, maybe a little bit of flavor, or extra kernels of corn, whatever. And so you do agree that mutations, or that there are mutations that allow us to evolve these corn or strawberries or whatever.
No, I would be cautious going down that trail. The corn, they're selecting for size. If they get a mutant that is now larger size, okay, is that new information, or is that the same information gone haywire? There's no new. The corn didn't turn into a strawberry or banana or elephant. It is still corn. It's still recognizable as corn. So I don't think the mutation actually added anything. It accentuated something that was already existing. So I don't think that process is going to offer any hope to those who want all of humans to come from rocks over 4.6 billion years.
Okay.
Okay.
I think.
Well, let me point out one more thing, Jackson. One more thing.
Go ahead.
One more thing. This corn that they have produced, and I grew up in Illinois corn country. Believe me, we were surrounded by miles of corn. The corn is A, still corn. B, it is less resistant to diseases. You have to babysit it and spray it with all kinds of stuff. And it turned loose into the wild, it would very quickly revert in a couple generations, if it survived at all. It would revert back to the native original corn. So this is not something that is going to work in nature. It might work in a farm or in a laboratory where they can babysit it and keep it alive, but it has lost its disease resistance, it's lost its resilience, it's lost its toughness. I think there's a couple of other phrases that farmers will use for plants that are able to survive, without their help. So that example, if it were true that the corn has indeed evolved or mutated and created something new, if it were true, and I'm not saying it is, that is only one of about 40 quadrillion examples you would have to come up with to turn a rock to a human over 4.6 billion years.
Okay, so I think, and it's probably my fault, but I think we are talking about two different types of mutations. I think we're on two different sort of wavelengths when we talk about this.
Okay, go ahead.
Okay, I agree with you completely when you say that it's built upon, that mutations are built upon the existing genetic material. I completely agree. Elephants don't, just come out of rocks magically or what have you. I agree.
Right.
But every variation, every mutation is adding to what's already there. And so when we pull those away, when we look at these mutations, over time we see a sort of family tree arising from these mutations, or from pulling them away. We see, okay, this mutation resulted in this lineage, and we see this mutation resulted in some other lineage. And so I agree, they are starting with a pre-existing material, but they are still adding information, I guess.
Well, that's where I would disagree. I don't think, this is a fairy tale that people tell. This is a story, but it's not observed in nature. We don't observe mutations add information that is useful and then succeed in passing it on to the next generations. We don't see that in nature. So it's not really science. It's more of a religion. It's something people believe in, and they believe in it very strongly. And I have to admire their faith. But it's not science. Whatever it is, science is things we can see and test and observe and study and demonstrate. So it's not science. It is a story. It's if you give it enough time, it might happen. Well, okay. We've had farmers raising cows and pigs and corn and chickens and everything else for generations, thousands of years. And all we've ever seen is chickens produce chickens and cows produce cows. And if you get a mutation that's too far from normal, it dies. The second problem you have is if you did get a beneficial mutation, like you're mentioning here, I don't think there's an example of one. But if there was one, now you got a gigantic problem of who does this one marry? You got to get two mutations, identical, in the opposite sex, at the same time, in the same place. They got to find each other and be interested.
Well, that's not really how sex works. But it's not so much about two getting the same mutation at the same time. It's about one. Mutations are very incremental, and so a mutation that isn't within a certain range of incrementalness, whatever, is going to kill the organism, which is why we have all these mutations that are lethal, because they cause too much of a negative change in this organism. But that's right. So I want to go back to this idea of information. can you give me a definition of that word? Does that just mean genes?
Well,
it just means gene?
The English language is based upon a code of 26 letters called the 26 letters of the alphabet. If you had mutations in your writing, if you were writing down in English and every once in a while you get a mutation, a misspelling, how long would it take that process of getting mutations or typographical errors or misspellings to turn your sentence into Russian or Chinese or Korean? Well, it won't happen. It doesn't happen. It can't.
I mean, we can... I'm sorry.
Well, it's based on a different code. See, adding letters or deleting letters or transposing letters in a sentence, as an example of a mutation, is not going to add new information, especially if anything wrong or negative is eliminated right away. And there certainly seems to be a process in nature called natural selection, where anything that isn't the best or toughest or strongest is going to be naturally eliminated. It's not going to survive. If the sheep can't run as fast as the rest of the sheep, well, then the wolf is going to catch him first. So he doesn't get to pass on his genes to the next generation. I don't think that mutations are incremental. I mean, you can imagine that if you want, but that's not science. It's something people imagine happening, and they tell stories about it, and they say, well, what if, and what if, and it's not science. Whatever it is, it's a religion, I think.
Okay. So I guess we'll talk about the. You mentioned languages as you're talking about mutation. Well, we can actually see the evolution of languages. We can see the evolution from Latin to Old Castilian, which is the colloquialism of Latin, or colloquial language of Latin, to Spanish, for instance. And we can see the evolution, if you want to call it that, in such works as Don Quixote, which has elements of both Old Castilian, which is the Latin colloquial language, and Spanish.
Sure.
So we can see...
Hold on. Let me give my input on that so far, and then you can go on. That is a poor example of using the word evolution, because that didn't happen by itself. There were a lot of intelligent people over the centuries who were making those changes. People in the last 100 years have come up with thousands of brand new words. I don't know that the word computer was in any dictionary 200 years ago. I don't think the word automobile was in any dictionary 100 years ago or 150 years ago. So, yes, we are all, our English language is evolving, if that's what you mean, but it's happening as a result of a lot of intelligent, or sometimes not so intelligent, input. So the Latin slowly evolving or morphing into the Spanish or any of the modern Romance languages, this is not happening by itself. It's happening because of intelligent input. That is not an example of what might happen in nature to turn a frog to a prince, or to turn a rock to a prince, which is what evolution really teaches. I mean, ultimately, you have to start with a rock. 4.6 billion years ago, the Earth cooled down. It was a hard, rocky crust. It rained on the rocks for millions of years, turned them into soup, and the soup came alive. And that first life form slowly became humans. I mean, that is exactly what the story says. I've got the textbooks. I'm surrounded by a library of these textbooks that teach that. So,
I believe you.
The changes that we see from Latin to Spanish is A, not going to help for the evolution of living forms. B, it's an example of intelligent input causing this to happen. Like the automobile turning into the, from the Model T to the Lincoln Continental. Well, that didn't happen by itself. A whole lot of engineers designed things and made them better. So that was an example of creation and intelligence. So I'm sorry, go ahead, I interrupted.
No, that's fine. Well, I was just making the analogy with language.
Right.
That wasn't meant to be as, like this is a dead...
A proof. It's not a proof.
Yeah. I was just making an analogy. As for the mutations, they are incremental. Everyone has approximately 130 mutations in their zygote alone, and the majority of these are neutral. That is, they don't express themselves, and this is understood in Kimura's neutral theory or neutral theory of mutation, I believe it's called. And so when we look, when we look at evolution over the billions of years, when we look at it in retrospect, and it seems kind of difficult to imagine that, the single-celled organism eventually unconsciously gave rise to multicellular organisms and then to fish, amphibians, etc. But we have to realize, looking at that in retrospect, in every generation throughout evolutionary time, there was no conscious foresight of what any organism is going to turn into. Every organism was just going through mutation, natural selection, and speciation, and it ultimately resulted in us as well as all the other organisms.
Well, now, hold on. No. You think it ultimately did that. You don't know that. That is how the story goes, but that's not science. Nobody saw this happen. Nobody sees it happen today. It is a religious teaching that single-celled organisms became humans over slow periods of time, over billions and billions of years. That is certainly what you're being taught, and that is what you voiced here, but that is not part of science. It's part of a religion that you believe in. And it may be true, but even if it's true, it's not part of science in this case. It's an example of something that can't be observed and studied and tested. It's a story. It's a fairy tale, I think. Now, let me make 2 points here before you go on. Single-celled organisms changing to multi-celled. Are you aware of any 2 or 3 or 4 or 5-celled organisms that survive, other than a colony where each organism is doing the same thing? Are there any 2-celled organisms in the universe that you're aware of, or that anybody's aware of, or 3-celled or 4-celled? And I can answer the question by saying nobody's found one yet. I think the simplest life form that has multiple functions is about probably maybe 200 cells working together. So where are the 2-celled or the 3-celled or the 4-celled? I mean, the human body is probably 100 trillion cells working together to do the functions that we do. So to say it went from single cell to multicellular is great to say. Those words roll off the tongue easily, but it's not science.
Okay. And what's your second point?
Now, secondly, you mentioned that we have 130 mutations in our zygote. I don't know that that's true, but let's assume that it is. I think it's more than that.
Okay.
None of these mutations are helpful that anybody's aware of. And if you marry too close to your own bloodline, like your sister or mother or daughter, you're probably going to have deformed children, because now the chances of those 130 mutations lining up are much greater, which is why most states have laws, banning anything closer than second cousin marriages. I think 3 states allow first cousin marriages, but because it creates problems. So that's just, I would say that's a proof, a demonstration that the mutations that are happening are not helpful. They're harmful. And so gradually they get weeded out of the population by virtue of the fact that we don't marry our sister. Okay. That would be the dominant and recessive genes that you learn in high school biology, that gradually things can be weeded out. If there's a mistake in your genetic code, and it's a really complicated code, and the copying process is phenomenal, the way DNA replicates, it's just like mind-boggling how this could happen. But it could be like a computer code or a language or anything else, and there simply are no examples of it being beneficial, and certainly plenty of examples of it being harmful or fatal. Go ahead.
Okay. So I guess I wrote down kind of 3 things while you were talking. The first thing you said was that I just want to make sure that these are correct before I talk about them. I don't want to misrepresent what you're saying.
Okay.
You said science is direct observation and experimentation.
The definition of science needs to be agreed on before you go too far in a debate like this, but I think most dictionaries would list science from the word seer, which is the Latin, means to know. What do we know? And how do we know it? Well, we know things that we can observe, study, test, and demonstrate. That would be observational science. Now, there's another type called historical science. I know Abe Lincoln was president of the United States, even though I can't see him. So the historical science is not as credible, I guess, as observational science, but it's still credible up to a degree. But evolution is neither of those. It's not something we know. We don't know that animals turn to any other kind of animals. We know there are cows and bananas in the world today. I think that is part of science. We know that. We do not know that they had a common ancestor that was a single-celled organism, 3 billion years ago. We don't know that. We can think that if we want. We can believe that if we want. We can believe it very strongly. And we might be able to convince millions of other people to believe it. But that's not science. It's a religion in every sense of the word. So yes, I did give that definition of science, and I think if you look up any dictionary, unless they changed it in the new ones, go back and get some. I got some old ones here in the library. Okay, go ahead.
A systematic knowledge of the physical world gained through observation and experimentation. Would you say that's a fair definition?
That is typically a definition that's given, something like that. Systematic, it's the accumulation of knowledge gained by observation, experimentation, testing.
All right. Okay. Good. Okay. So would you consider inference part of the scientific method?
Yes, we can certainly infer things. Okay, but you start to lose certainty. I can tap on a block of wood and infer that it's probably solid wood all the way through. But I may, cut it in half and find out, oh no, it actually has, a hollow spot in it. Until I actually do scientific experiments, I wouldn't be able to say that my inference is the same as observational science. It may be, but we can infer what's inside the Earth by the S&P waves from earthquakes and tsunamis and things like that. How the waves travel through the crust of the Earth. I think it's a very reasonable inference and is probably true, but it doesn't rise to the level of first-class, provable, demonstrable science.
Okay. Okay. Well, let me see. Okay, so we agree on the definition of science. We agree that science is about observation, experimentation, and inference. Those are all important to understanding the world. Okay, so in that case, I'd like to say that the reason that I accept that evolution has happened it's not because I was raised in an area where evolution is exceptionally supported, I guess. I mean, I was raised in Louisiana. There are creationists in my family. I've actually got several creationist books, believe it or not. One by Lee Strobel. I've got Did Man Get Here by Evolution or by Creation? From 1969, I think it is. And so I came to my understanding of evolution because of the inferences that can be drawn from all of the observational and experiments. And so these observation experiments come from biogeography, the fossil record, phobology, geology, embryology.
Hold on. Slow down. Before you list all these, let's go take them one at a time. You're saying you came to this.
I was just making a point about those are what have pushed me to accept evolution, but we don't have to get into those. No,
I think you named them. I think we need to take them one at a time. Because
I still wanted to get to the points you mentioned earlier about multicellular organisms and human mutation.
Okay, but if you studied embryology or fossil record, etc., and those led you to the conclusion, I don't know if you've seen my video series or not, but I point out.
No, sir, I haven't.
Okay, there is no such thing as a fossil record. It doesn't exist. There are fossils, bazillions of fossils in the ground. That's not a question. But it's not a record. None of them talk, and none of them have a date. None of them have a date stamped on them. So somebody else is telling the story about what happened to form these fossils. Now, the story they're telling may be true, or it may not be true. But there is no such thing as a fossil record. There are bones in the dirt, lots of them. But that doesn't mean we can tell exactly what happened. And I point out, in a court of law, no fossils would count as evidence for evolution, because you can't prove that one had any children. When you find bones in the dirt, all you really know is it died. You don't know it had any children that lived, or it had any children at all. So in a court of law, in an honest court of law, all fossil evidence would be thrown out. Their fossil records, they would say, I object, that doesn't prove anything. Yep, I agree. And they wouldn't allow it as evidence for evolution. Embryology, they're probably teaching you in school that the baby growing inside the mother has gill slits, and they go through the pharyngeal gill arches. That was proven wrong in 1874, but they're still teaching it in schools, and sadly, it sounds like you got taught that. My video number four, which you can see on drdino.com, just watch seminar part 4, Lies in the Textbooks. And I've got a whole section in there showing about embryology, how it was made up in 1869, proven wrong in proven wrong 5 years later, but they still teach it. I've got biology books, let's see, right behind me here. I can grab one. They're still teaching this, even though it's been proven wrong 130 years ago. It's not true.
Well, okay, so on that, I think you're confusing the drawing that Haeckel did where he exaggerated the pharyngeal arches for, I actually have a biology textbook right here, Campbell 9th edition, where it's got micrograph pictures of these embryos. I mean, they didn't make up the micrograph pictures.
No, that I agree. I might have. I don't know if I have Campbell's 9th edition or not, but I'm looking around my library here. I've got Campbell's. There it is over there. I'm not sure which edition it is. Okay, it is true that many creatures, as they develop in the mother, have what would be considered folds of skin under what is going to become the head. That is true. Okay, I have folds of skin in my elbow when I bend it. Also, I cannot breathe through them.
I think that's kind of a mischaracterization of what these things are. What the textbooks aren't saying is that these are gill arches. It's saying these are homologous to the gill arches in fish. These pharyngeal gill arches in us, or pharyngeal arches, whatever you want to call them, they developed into our face, part of our neck, etc., our larynx, but they were homologous to the things that developed into gills in fish.
Right. Let me explain that. Homologous, homo means same. Homologous means this looks like it might be the same thing. Okay. Well, I would say a watermelon and a what's that game they play? Rugby. A rugby ball look very similar. They're homologous. But
no, that's not what.
Yes, it is.
Homologous means homologous is you look at the fingernails, for instance. We have fingernails. All primates have fingernails. There are some strepsirrhines that have claws also, and they're kind of weird. But all primates have fingernails, and we all derive our fingernails, which are homologous, from a common ancestor.
No. Stop, Jackson, stop right there. Could it be we all have fingernails because we have a common designer? Why would you say a common ancestor? That is not evidence of a common ancestor. Toyotas and Chevys have bumpers. Wow, that proves they all evolved from a skateboard. No, it doesn't. It's a common design. It meets a necessary function. You have bumpers on your car. You have fingernails on your fingers so you can do things. You can scratch things and open things. The fingernails are very handy. I'm glad I've got some. But that's not proof of a common ancestor. Whoever taught you that lied to you. It is true. It is true. We all have similar structures. Now that I would agree with. But it is not true that that's evidence for evolution. I think that's evidence of the same creator created us.
Okay, so I've got two things to say, and I'll say them, and then I guess you can address them. The first thing, your point of comparison is something that you know is created by humans versus something you know isn't created by humans. So I think that's kind of a false analogy. Secondarily, you said, is it possible that it is a common creator? Well, yes, it's possible that it was a common creator. I'm not going to get into about what that creator was like or anything like that. Mm-hmm. But if we assume it was a common creator, then why did that creator create some differences in some organisms and some differences in other organisms? Why not just create all organisms the same?
Okay.
What is the reason?
Let me take the second question first. The reason I would say that the creator made these similarities is we have similar things to do in life. We have two eyes, so do the apes. That's so we can get binocular vision to judge distances. A creature with one eye is certainly handicapped. They can't have depth perception, and it would be a hindrance. So there may be some creatures like an octopus that can survive just fine with one in their little world. But they're designed to fit whatever their duty is going to be in life. The differences then would be for the same reason. Let's see, you could design a Chevy pickup truck or a Chevy van. They have thousands of similarities, probably thousands of interchangeable parts, because they came from the same designer. But there are also some differences between a pickup truck and a van because they have different functions. The apes have to climb trees. I don't. Not apes. I'm sorry, monkeys. Monkeys have to climb trees to survive. I don't. So they have a prehensile tail and a grasping rear foot, which I do not have, and you don't either. You can't grab a tree branch with your feet and hang on upside down by it. So monkeys have to live they're designed to live in their world, which is mostly up in the trees, arboreal, and we are not. So the similarities could be attributed to a common designer, and the differences could be attributed to a common designer. I don't see any problem with that.
Kind of a heads I win, tails you lose situation?
Well, I think in a court of law, see, since you are asking, or the evolutionists, I should say, aren't asking nothing, they're demanding that their view be taught at taxpayer expense to all the kids. The burden of proof is on them. It's not on me. I'm not asking for my view to be taught. So it's not heads I win, tails you lose. The fact is, the similarities and differences could be a common ancestor or could be a common creator. So why are all of us paying for the common ancestor theory to be taught? A, that's not fair. B, that's not common sense. I don't think we should have public schools at all, but if we're going to have them, then certainly don't promote one person's religion over another. And the idea that we have a common ancestor because we all have fingernails, that is a religious belief. That is not scientifically observable. Monkeys are still producing babies, and they still have fingernails. And humans are still producing babies, and they still have fingernails. But we never see anything changing even closely toward the other kind. Apes produce apes, monkeys produce monkeys, gorillas produce gorillas, humans produce humans, squirrels produce squirrels. There are no exceptions. None.
Okay. So one thing, I didn't say that common ancestry is proved because we have fingernails. I was just using that as an example. There are lots of other examples I could use.
Right.
And the point that I was making is that we have all these similarities with other apes, and we have similarities with monkeys, and we have similarities with mammals.
I agree.
And we also have similarities with reptiles and amphibians and fish, and we even have similarities with prokaryotic unicellular organisms.
Oh, sure.
And so when you look at the wealth of similarities, this hierarchy forms, and that hierarchy, just based on the morphological characteristics alone, is in the vast majority of cases shown to be true by genetics.
Okay.
We use morphology, and we also use genetics, and in a lot of cases, not in all cases, I'll grant you, but in the vast majority of cases, they give us the same picture. We share 98% of our, 97% of our DNA with chimpanzees. We also share the exact same amount of endogenous retroviruses with chimpanzees, and we both have the broken monkey gene for making citrate. It's called a gulo. Mm-hmm. It's broken in us, but it's not broken, and also in other apes, but not in monkeys. And so this hierarchy of genetics and morphology starts to line up, and so that's where, or at least that's partially where, the phylogenetic tree arises. And so that's what I have to say on.
Okay, hold on 1 second here. If you don't mind, I'd like to, so my YouTubes are not much more than 30 minutes. Let me stop and start a new one. Okay, I'm Jackson. Thank you so much for doing this. I'm back. This will be part 2 of our discussion. You are a college student in Louisiana being taught evolution, and you're giving me the examples of evolution. You said that we have 98% DNA similarity with chimps. Okay, that's where we left off. And that is simply not correct. Okay, it's about 91% similarity. But the DNA code is so complicated that even a 1,000th of 1% difference could be fatal, a change from the DNA. And again, I would point out the similar DNA probably proves a common designer, not a common ancestor. I think if you look at all the writings of Edgar Allan Poe, you would find thousands of similarities. Yes, that's this coming from the same mind, perverted and twisted as it was. It's coming from the same mind. That's why, the Telltale Heart has some similarities to his other writings. Okay, well, that's the fact that there are similarities in DNA and even maybe retroviruses, some kind of weakness in the system that allows this to happen, could be, again, from the same designer. It is not evidence. What happens in colleges typically, Jackson, the teacher will impress the students by listing off 20 or 30 or 40 evidences for evolution. Each one on its own will not stand up to scrutiny. Every single one can be refuted easily, which is why when you started naming off all the branches of science that support evolution, embryology, etc., I said, whoa, take these one at a time. No, they don't. But somebody convinced you somewhere along the line that all these similarities and all these branches of science all point to the same thing, and they don't. You're being lied to. You need to get your money back for this degree. So the phylogenetic, there's no phylogenetic tree. It's an orchard. All of the foxes, wolves, coyotes, dogs probably had a common ancestor. That would be one tree, a phylogenetic tree. All of the apples, and there are 2,000 different species of apples now, they might have had a common ancestor, and it was an apple. That does not prove apples and dogs are related. It's a completely different tree. There are 5 different varieties, or species actually, 5 species of giraffe. They might have had a common ancestor, and it was a giraffe. There are 8 kinds of bears in the world, black bear, grizzly bear, panda bear, etc. They probably had a common ancestor, and it was a bear. What we observe in nature and in reality and in science and even in the laboratory, what we observe is everything produces after the same kind. And people would recognize a grizzly bear and black bear and brown bear and panda bear as a bear. It's the same kind of animal. Now, there's lots of differences, and so the Chihuahua and the Great Dane are pretty different. But they're both recognizable to a 5-year-old as being a dog. They're in the same family. I don't know that our current classification system, developed by Carolus Linnaeus, matches God's classification system of kind. It probably doesn't at all places, but I would say somewhere around the family level would probably be better than the species level. So what you're going to do in school, Jackson, they're going to show you a bunch of examples of new species, like there's now, I think, 80 or maybe 100 species of ladybugs, based on the number of spots and the position of the spots and the length of the legs. And somebody got a government grant to study all this, I'm sure. And, okay, there's still a bug. It's a ladybug. That's not evolution. It's not going to even help the evolution theory. It's the same kind of animal. There are no examples anywhere in history or anywhere in the present, or anywhere in the fossil record. There's no fossil record in the fossils. There are no examples of any animal ever producing anything other than its kind. If you want to think it happened or believe it happened, you are welcome to. But see, the evolutionist is demanding that everybody pay for his religion to be taught. And that's the way it is in America right now. All the taxpayers are forced to pay for the religion of evolution to be taught. And if you don't want to pay your property taxes that support your schools, well, then they'll come take away your house. It is absolutely forced on everybody to pay for this one religion. Okay, go ahead. Next point.
Okay, so I'm glad that kinds were brought up because I think that was mentioned a little earlier, and I was wondering about that, and so I wrote it down, and so I'm glad we kind of came back to that.
Okay.
There was something else I wanted to say, and I forgot what it was, unfortunately. But anyways, oh, that's right. So the definition of evolution is genetic change in a population, genetic change in a population over time.
Well, now, hold it.
Would you agree to that?
No. This is where the problem comes in. You have to define the word evolution. Exactly what are we talking about? Because what they're going to do, Jackson, in school, there are actually 6 different meanings to the word evolution. 6 different levels or stages. If you want to write these down, this will help make it much simpler. Number 1 is cosmic evolution. Where did time, space, and matter come from? they'll say the Big Bang. Okay, what exploded? Where did it come from? And where did the energy come from? And why are there laws like the law of gravity and inertia and centrifugal force and the laws of the pendulum, etc.? Why are there any laws? Where did they come from? So cosmic evolution is a giant obstacle, I think, to those who want humans and strawberries to be related. Secondly, you have to have what's called chemical evolution. According to the Big Bang theory, the Big Bang would have produced hydrogen and maybe some helium. That's not observable, it's just a religious belief, but suppose it's true. Well, how do you change helium or hydrogen into gold, silver, and platinum?
Well, actually, that part has been observed.
No, that's
the process of radio astronomy. You can what scientists do. There was a woman in the earlier 1900s, I think it was, and they use these special telescopes, and they look at stars, and they can see that within the stars these elements are being matched. They can see that they're matched together, and that's where Einstein's theory of relativity comes in, E equals mc squared. So a lot of energy, which is what the star is powered by, is produced when you take these hydrogen or helium atoms and you smash them together, and they become, and so it's this teeny tiny bit of mass that produces a huge amount of energy.
Correct, but see, you have a chicken and an egg. You got a chicken and an egg problem here. You have that's called fusion. What you're referring to, you can't fuse past iron. As far as I've never heard of anybody being able to use fusion to go past iron. And the energy input is phenomenal compared to the result. And so now you have, where did this star come from, which is the third part of evolution, stellar evolution. The stars have to form, and nobody's ever seen a star form. The current estimate, at least the last I heard, was there are 70 sextillion stars that are observable from Earth with the big telescopes. So that would mean everybody on Earth could own about 11 trillion stars to yourself. We see stars blow up occasionally. It's called a nova or a supernova. But nobody's ever seen any stars forming. And
well, actually, there was about 2 years ago, there was a quadruple star birth that was observed. I believe it was, or I remember seeing the article in, was it BBC News, but there was a quadruple star birth that was on record. That's the only one I know of, though.
So you're saying they watched a quadruple star birth?
That's what I remember the article saying. I don't remember. I'd have to look up the article.
Yeah, I'd like you to send me that. I'd like to look at that, because I would predict they started with a big star, like Betelgeuse or something, and it broke down into 4 pieces. That is not stars forming from gas.
Here it is. I found an article. This is not the original website that I saw it, but this is okay. Yeah, I'll just send it to you. Okay.
Okay. Yeah, please do. Now, but stellar evolution, I think, is a royal problem, because we've never, to my knowledge, never seen a star form. Certainly, the idea of gases condensing into a solid is counterintuitive to all known physics today. Gases, when you try to compress them, they build up pressure and they expand away from each other. It takes enormous pressure to condense gas. I mean, you got to have an air compressor or something like that. Where's this energy coming from? So, number 3, my point would be stellar evolution, I think, is a giant problem for the evolution, for the general evolution theory. I'm defining the word evolution. Number 4, you have to have organic evolution. Somewhere, somehow, non-living material, stardust, has to come alive. Now, whether it comes in a single cell or a multi-cell doesn't matter. The fact is, there's a difference between living and non-living. And this is not something dead coming to life. It's something that never was alive. All of a sudden, you go from non-life to life. That is a giant step called organic evolution, and there's no evidence of it happening. No, they can't even make it happen in the laboratory. Number 5, if you want to write this down, is macroevolution. Macroevolution is where an animal changes to a different kind of animal. Number 6 is called microevolution. This is variations within the kind. That's what you gave a definition of. That one is actually science. I believe in microevolution. I do not believe it adds up to anything other than that. Dogs may produce a big dog or a little dog, but it's always going to be a dog. So defining the word evolution, the way you started to was, I started writing it down, I missed it here.
A change in the gene pool of a population from generation to generation.
Okay, now stop. Right, stop and think for a minute. That means you've already got the gene pool. Genes are incredibly complicated. You've already got this phenomenally complex. The genetic code of any organisms is more complex than probably all the computer programs written by man combined. So the genetic code in one cell of your body, just the genetic code in there, is more complicated than all the computer programs ever written in humanity. So if you want to start with that and say, now we have changes within this code, well, you're down in number 6 on my list. You're taking what's called microevolution, and that happens. Variations happen within the kind for the reasons you've stated. Mutations happen. Radiation causes things. All kinds of things can cause mutations. That's a pretty well-studied topic. But the question is, do these mutations result in some improvement, or are they detrimental? If you could find one that was an improvement, you're back to the question of, okay, who's it going to marry? How's it going to pass this on? And it's an awfully big world, so this improved version has to somehow take over the whole world to spread its genes. So if you got an improved horse, not only do you have to have 2 of them, all the other horses have to die for this to work. So what your definition that you gave is really a classic example of number 6, which I agree, it happens. Microevolution, but it's not any evidence for anything beyond that.
So microevolution is defined as genetic change below the level of species?
No, I wouldn't use the word species. I use the word kind.
I don't really know what...
Nobody's ever given a good definition of species. A dog and a wolf are different species. But they're
actually different subspecies of Canis lupus.
No, Canis domesticus, Canis lupus, Canis coyotes, they are all different species, but they can interbreed. They normally don't, but they can. A zebra and a horse are clearly different species, but they can interbreed and produce a zorse. So the fact that they can interbreed, to me, indicates they probably come from the original kind. The Bible says they will bring forth after their kind. That is, they will produce offspring after their kind. It's mentioned 20 times in Genesis 1 and Genesis 6 and 7. So I agree.
Okay.
I agree that animals can produce. If they can produce, they're probably the same kind. And studying exactly where the border is to define a kind would be a good endeavor for science to follow. But the fact that we don't know exactly what the kinds are in every case, I think we do in most cases, but I think that'd be a wonderful biological pursuit. However, I did not say species. A dog and a wolf are different species, yet they can interbreed. So exactly what is the definition of a species?
Okay. So I looked it up. And right now it says dogs are Canis lupus familiaris, which I thought they were.
Okay.
Familiaris is the subspecies of Canis lupus, which is what our house dogs
are,
and Canis lupus is the gray wolf.
Okay, well, let's take the zebra and the horse instead. Maybe that'll give a completely different species name. I forget what they are.
I mean, those are definitely different species.
Can they interbreed?
Equus and I don't remember what the zebra is.
I don't either. It doesn't matter. But can they interbreed?
Probably not. I would imagine.
Just type in Zorse, Z-O-R-S-E.
Okay.
A horse and a zebra can interbreed. They don't normally, but they can. You can type in Pizzly, P-I-Z-L-E-Y, a Pizzly bear, a cross between a grizzly, and something else. I forget what they did.
Is it a panda?
I don't remember.
Or a polar bear?
I think it's a polar bear and a grizzly. I think. Okay. Now they're completely different species. Nobody argues about that. But they're the same kind of animal. It's a bear.
Okay. All right. So I guess. If we're talking about kind, I guess I want to ask a series of yes/no questions to kind of figure out what kind means. I mean, this will help. This will help me to understand what kind means.
Okay.
So, I want to ask. So, the house cat, which is Felis domesticus.
Right.
Right. You would say that is the same kind as a lion?
I would say probably they derived from the same kind. Somebody spent years crossbreeding who knows what, whether it was lions or tigers or bobcats or lynx, or there may be 20 or 30 different varieties in the cat family. And I don't know if Noah simply had 2 cats on the ark and they diversified into all of those, or maybe he had 10 pairs of cats because there are 10 varieties in the cat family. I don't know. But today we have bobcat and lynx and jaguar and, I don't know, pick a number. Say there are 15 or 20 different kinds of cats. The domestic house cat, I think, probably was domesticated from something, one of those, and probably would not, most of them would not survive in nature. So that they would be quickly selected against if it weren't for humans babysitting them.
So house cats and lions and bobcats, those are all the same kind, I guess. They're all in these.
Well, I didn't say that, but I think that's a possibility. Or maybe there are 2 or 3 basic kinds of cats that they derive from. I don't know the answer to that. And again, that would be a good pursuit for some biologists to say, okay, can you get a house cat from a lion if you choose through selective breeding? I will guarantee this: you will not get a house cat from an elephant, no matter how many generations you go through. Nor will you get one from a dog. Now, the lion is maybe close enough to do that. I don't know. But
okay.
I did not.
Well, the lion is. Sorry.
I did not say they're the same kind. I said they might be. The lion, lions and tigers can interbreed, and they get a liger or a tigon, depending which one is the male. They breed both ways.
Okay.
So you can look up ligon, Ligon. Now,
okay.
They normally are sterile, the offspring, just like a horse and a jackass produce a mule, which is nearly always sterile. I think 1 in 20,000 maybe not sterile. But then it'll quickly revert back to one or the other, depending which is the male, I think is how it goes. So the point is, even a horse and a mule or a horse and a jackass are the same kind of animal, 4-wheel drive, leather upholstery, recognizable as the horse family. This would not offer any evidence that a horse and a butterfly are related. But I would be willing I'd be willing to bet any amount of money you want that your professors believe horses and butterflies are related if you go back far enough in time.
Well, I'm sure they are.
Okay.
I'm sure they do believe.
Sure. Well, you tell them I said, A, they're welcome to believe that, but they should stop calling it science. B, I will come to your university and debate every professor you've got there at the same time, 20 against 1, on the condition that I get half the time and we discuss one topic at a time. So I'll take on the whole faculty. I don't even know what university it is, but it doesn't matter. I'll take them on.
Okay, well, I go to LSU Baton Rouge if
Okay.
you're ever in town.
No, I'll drive over special for that. I'm only 4 hours away from Baton Rouge. I'll come over just for that. You get I tell you what, ask all the professors, will you debate Kent Hovind? They will say no. And then go ahead and get a room. You know, any club on campus can get a room for free. Get the chess club or the drama club or something. Say we want to rent this or get this auditorium, and have me come speak. And I'll have question answer for the whole audience. I'll take them all on.
Okay. Well, so I want to stick with the topic of kinds. I also want to say you want to avoid traffic between 3 and 5.
Okay, no problem. Baton Rouge, do they have driving tests or light at all in Louisiana? They drive like maniacs.
I mean, that's why I miss Shreveport so much, because if something 20 miles away, it takes 20 minutes to get there. In Baton Rouge, it might take you at least an hour.
Well, you need to come to Lenox, Alabama. We had a car go by yesterday. And that's about the extent of our traffic here.
Yeah. Okay, so I'm sorry?
Population 35. We love it here. Okay, so the definition of kind, I don't know that I can give you an airtight definition. I think most of them are intuitive and are obvious at first glance to a 5-year-old, that a dog and a wolf and a coyote are the same kind of animal. But a 5-year-old would recognize a dog and a banana as not being the same kind. And I don't know how many varieties of bananas there are, but they are still a banana. As I mentioned, I think there are 1,000 species now of bamboo. Okay, it's still a plant.
So if so we'll do the 5-year-old test, I guess. If you were to put up a picture of, a house cat, a cuvette, and a fox, and then a banana, wouldn't the child classify the fox, cuvette, and house cat as one kind?
I think they would classify the fox, the cuvette, and the house cat as animals as opposed to plants. Yes, they would distinguish that, the 5-year-old test. But I think they would distinguish the cat and the civet as both in the cat family and would say, no, the fox is not in that family. It's not the same kind of animal. It's an animal, but it's not the same kind of animal. I would guess. We got a 5-year-old running around the yard here. I can go grab him if you'd like, and I'll give him the test.
You don't have to do that.
Okay.
Thank you. So cuvettes and the house cat are both in the order Feliformes. Cats are on essentially one family tree with the Panthera and the felids and hyenas and felis and hyenas.
Yeah.
And the cuvettes are on another tree that is closely related with genettes and linsangs and all these other more odd, like cat-like animals that we don't really see a lot or talk about much. And so you wouldn't say, or I don't know, this is what I'm asking. So would you say that those are all cat kind or not? Or you wouldn't? Or would you say that there's not good reason to say that they're not all one kind?
That's a good question, and as I've said a couple times, that would be a good biological pursuit to determine exactly where is the border for kind. Certainly, species is a real blurry word, and
depending on which definition, I guess.
Well, if they go by reproductive, population, or reproductive possibility, a dog and a wolf and a coyote can all interbreed. A coyote and a wolf can. They don't normally, but they can.
Okay.
A Great Dane and a Chihuahua can interbreed. Yeah, whether they produce fertile offspring is another. You could decide to make that part of your definition. I don't know. The horse and the ass can produce offspring, but it's normally not fertile. The mule is, I think it's 1 out of 20,000 is fertile, but it's normally not. Now, you brought up a flower earlier before I asked you, hey, can we record this conversation?
Oh, yeah.
Let's talk about that and tell me what you thought that proved. I've got a picture of it on my screen here for everybody to see.
Okay, so I was just pointing out, I wasn't saying necessarily that this flower proves evolution or anything as far-reaching as that. I was just making a point about mutations, that there are mutations that can increase the viability of organisms. It can help them. There are mutations that I guess you might call beneficial that will help them survive and reproduce and pass on these traits to offspring. And so with the slender clarkia, which was the flower I mentioned earlier.
Okay, let me repeat that for people to look it up. Slender clarkia, like the name Clark. Slender clarkia flower, correct. There's probably hundreds of varieties of that, but I've got a picture of one on the screen.
Is it like purple and pink?
Yeah, the outer is pink, and there's kind of a purple heart in the middle, or a real dark pink in the middle. Now,
sorry?
I could go back to Google and pull up 50 pictures, but anybody can do that. Slender clarkia is a flower that produces a variety of colors, generally around the pink or purple color band, right?
Yes.
Okay.
So there was a slender clarkia that went through one species, I suppose, that went through a genome duplication, and in that duplicated genome, there was a mutation that allowed it to have a larger range of colors in its petals, so that it attracted a larger range of insects because they could see. They were more likely to see the colors of the flower. And I was just making a point about that, showing that there are mutations that benefit organisms in nature, rather than just organisms that are, cultivated by human farmers.
Right. Let me summarize the argument here. Certainly, there are flowers that produce a wide range of colors, and some may attract more insects because of their either more vibrant colors, or we're not sure how insects actually see these flowers. Do they get what exactly is attracting them? But okay, so if there's a slender clarkia that is now more vibrant colors or a deeper shade of purple or something, and more insects are attracted that were not previously attracted, So therefore, it has a greater chance of reproducing because the insects carry the pollen to the next plant. I agree. That's probably a good observation. I would point out that A, it is still a flower. It was always a flower. It didn't turn into anything else. And I don't know that the offspring, this brighter colored flower, is indeed more likely to survive in nature. Did that bring along with it any deleterious things? Is it now more disease prone? Or is there some enemy going to see it now that's going to wipe that out of the gene code because it's more visible? Just like albino animals don't normally survive long because the predators can see them too easily. They lose their camouflage. So I don't know if this flower lost some of its camouflage ability for certain predators that would wipe it out. So if it's true that it happened, and it certainly could be a good story, that maybe this would give it greater opportunity to reproduce, but there may be something we haven't seen yet as far as something, as I mentioned, deleterious, like losing its camouflage or less disease, more disease prone. That would have to be proven in a laboratory, and that would take, that'd be, again, a good field for biology. But it's still a flower. That's not going to turn a single-celled organism to a human over any amount of time.
Okay, I agree. I mean, that wasn't the point of me saying that. I was just pointing out that I just want to get us on the same page because I know
Sure.
that there are some people who think that there's no such thing as beneficial mutations anywhere.
Yeah,
and
okay.
I just wanted to make sure that we were on the same page in that
Well,
regard.
let me give you a qualified yes. I think if you're calling that beneficial mutation, it may be beneficial in a certain environment and not beneficial in other environments. Like the people in Africa that get sickle cell anemia are less likely to get malaria. So they would call that a beneficial mutation. Well, sickle cell anemia is not good. That is, that's like saying if you cut off your arms, you can't be handcuffed. Ha ha. Well, yeah, but, okay, I still need my arms, Okay.
Right. And in regards to that, I can come up. I know of a better example of human mutations that are definitely beneficial. And I mean, it's much better than cutting off your arms so you can't be handcuffed. For example, the LRP5 mutation, which causes increased bone density in this family, and I think it's the American Southwest or the Midwest, one of those, doesn't really matter. But so this family has a mutation in their LRP5, and this mutation has been looked at by geneticists and by doctors, and they don't see any downside to it.
Yes.
This family gets the benefit of increased bone density without, something like, I don't know, maybe calcium would be leached from some other source, so they would, end up dying eventually or something like that. But that doesn't happen. So what do you think of that one? Well,
that's interesting. If they have increased bone density, it's still dealing with a structure that already exists. It didn't add a bone. It didn't add a wing. It didn't add feathers. It increased the density of the bone. B, this might be an example of getting back something that was lost over the generations. Maybe everybody 5,000 years ago had increased bone density, and we've lost it for whatever reason, and this is an example of something coming back. So it's dealing with an existing code that is modifying. It's not adding new information would be the point. Secondly, I don't think we know that it's a benefit. I mean, increased bone density would mean you're less able to swim. I would think it would harm their swimming ability. All other things considered, they're not going to float as well. So, so maybe it's a benefit for one area of life and not a benefit somewhere else. I mean, birds have hollow bones. It would be a detriment for them to have increased bone density. They don't want that because now they can't fly as well. So, but again, that little example of a family getting a LRP5 mutation, a mutation in LRP5 gene, may indeed be helpful in some circumstances. We don't know. I think it's worthy of more study. But that is such a minor example compared to the big picture. You'd have to have trillions and trillions of these changes proven to be beneficial to change anything to a different kind of animal. Are they still human?
Are they still, absolutely.
Okay, so they're still the same kind. So that would be a variation within the kind, which really would qualify, even if it qualifies at all, would be number 6. Well, it's on my
Okay,
list. Okay. You also talked about polyploidy, and I got a picture of that now. If you want to give your example for that.
Right. Well, again, my example with the LRP5 as well as the slender here wasn't to show that these have become some new species of organisms. They're actually, they're observations of new species coming into existence based on the definition of the general biological species concept of species. But I was just showing that these beneficial mutations do in fact exist, and there are other ones. There's the apolipoprotein A1 mutation in the family of Milan, and there's tetrachromatic vision in some women.
Hold on, hang on, Jackson. We're at 30 minutes again. Let me stop. We'll go to part 3, and then I've got people coming to visit me in just a few minutes, and then I got to go to a graduation tonight. So I can do one more part after this. Hang on, let me stop this. All right, this will be part 3. I'm talking to Jackson on the phone, a student at Louisiana State University, and giving examples of mutations being beneficial. And you talk about a family in Italy, so that has to do with their vision. Was this a mutation, or what was it?
Okay, so this is another one I think we might have talked about on the phone. It's called apolipoprotein A1. I think they shorten it to A1 Milan because it's in the family of Milan. Right. And what it does is it allows them to ingest more cholesterol without getting all the negative side effects that come with that. For example, heart disease. And so this was just another example, which we talked about with LRP5, of beneficial mutations in humans. And so I'm just pointing out that we agree that these mutations, these beneficial mutations, do exist. And what I also want to point out was that I agree with you in saying that they are, I guess, contextually beneficial. Because if you look at, an African elephant, and elephants have 38 copies of the mutation, or 38 copies of a gene called, P38, I think it is. It's a tumor suppressor gene. Mm-hmm. So, that's great for them in Africa, where there's a lot of sun, and they also have they have reduced hair, and all these other things that help them survive in Africa. Well, that's great for them there, but if you were to drop a bunch of elephants in Antarctica, well, it wouldn't help them there. But that's the point. All mutations are contextually important. They're important to the organism in such and such environment, but that's how evolution works. It works on the
No, slow down. No. Jackson, that's not how evolution works. That is an example, I think, of the creator designing the creatures to survive in a variety of environments. General Motors puts a heater and an air conditioner in lots of their cars. What does that prove? Well, they're planning ahead. They don't know if it's going to a cold climate or a warm climate, so let's give them both. So if the designer gave the creatures an incredibly complex genetic code that is able to allow some of the offspring to survive in a wide range of environments, that's not evolution. That's intelligent design. That's planning ahead. That's an example of creation. Now, you said we agree that beneficial mutations exist. Let me correct the record on that. I don't know that we agree on that or not. I think the examples you've given may be beneficial in one context, but may be detrimental. Maybe that same mutation causes a problem. I don't know. I don't think it's been studied enough, but that little minor variation you talk about, like the African elephants with less hair on them, okay, that may be from a mutation, it may be from a disease, it may be, who knows, maybe something lost in the gene code. But going from lots of hair to little hair is losing, not gaining. And it might be beneficial if it's hot or something, but it may, like you said, drop them off in Antarctica, they wouldn't survive. So I'm not going to go on record as saying I agree with you that all mutations or any mutations have been proven to be beneficial. There are some that are still questionable, and the jury's still out. Some people want there to be beneficial mutations, but Jackson, you would need trillions of them for your theory to work. Trillions. And more than that. And the examples you're giving, I think, are pretty questionable, and they're still the same kind of creature. To me, you haven't given any examples of any evolution at all.
Okay, I guess agree that, I haven't given examples of evolution because, I gave you a definition of evolution earlier, but you said that was microevolution, which you said you do agree to. You said you do agree that microevolution happens. Again, I think there's kind of a misunderstanding is that all mutations, all organisms are meant to live in their own environment. They are naturally selected. They go through mutations and speciation in their own environment. They're not selected based upon what happens on the other side of the planet. Like African elephants, for instance, they're not selected based on what happens in Antarctica. They're selected and they have mutations and they go through speciation and whatnot based on what's in their own environment. And so that's the important distinction here, is that yes, these mutations are beneficial, but they're only contextually beneficial. It's not about whether an elephant can survive in Antarctica or whether it can survive in Africa. It's about they survive in Africa because that's where they went through these processes. They went through mutations and natural selection there in Africa, and that's the important point.
Well, hold on. We don't know that story's true. I mean, that's the story they give. Could it be that they live in Africa and India, the two different types of elephants that still live, as opposed to mammoth and mastodon, which probably are in the same family? Maybe that's where they spread out from Noah's Ark, had offspring. Some of them moved north and ended up dying because it got too cold. Some of them moved south and survived. There's many ways the story could be told. It is not evidence that evolution is the only answer, the only story that matches. The fact is, they're African elephants, and they have bigger ears. And they're Asian elephants that have smaller ears. Now, whether they can interbreed or not, I don't know. But I think to a 5-year-old that's still an elephant, it's the same kind of animal. They may have diversified to where they can no longer interbreed, but it's not evidence that that's where they evolved. These mutations caused these changes in that area because of the climate or diet or whatever. No, not at all evidence of that. It could just as easily be this is where they settled in from getting off of Noah's Ark 4,400 years ago. An elephant is incredibly complicated. To get an elephant from a single-celled organism would be a real miracle. For it to happen by chance, I think it's much more common sense to say, wow, this thing must have been designed by a really smart designer. But there are some people who don't like the idea of there being a God because they're afraid he might have some rules. Thou shalt not. And they don't want those rules, so they will deny the obvious, say there's a creator, to really avoid accountability to him. I don't know you at all, Jackson. I've never met you, and I don't know, and you don't have to answer this, but I would predict, if we dig deep enough, you really don't want there to be a creator to tell you what to do. You like this evolution theory. It gives you freedom from God.
Well, personally, whether or not God exists is besides the point. God could have, as there are many, many, many Christians who accept that evolution happens, and
hang on, Jackson. I want to object for a minute. You say there are many Christians that accept that evolution happened. I object to the word accept. That's a slanted journalism way of saying this. I would say there are many Christians who believe that evolution happened.
We can say believe. Okay.
Oh, absolutely. It's something you don't know that it happened. You've never seen a dog produce a non-dog, and neither has anybody else. You believe.
That's not what evolution requires, but
well, yeah, it is. No, just a minute now. Do you believe dogs came from something that was non-dog?
The way it works is that it's a whole bunch of incremental steps, and with every generation that produces can reproduce with each juxtaposed generation.
Correct.
So every organism is unless you're talking about plants and things get weird.
All right. Well,
but for animals, if we're talking about animals, then yes, every organism is still the same species while they're evolving, but passing down traits or whatever. We don't have to use the word evolution, but while they're evolving, but they are all still of the same species, and they can all still interbreed. So they are the same species while they're going, but it's only in retrospect that we can say this is where such and such new species has arisen. We can't really say that while we're watching the generations go by. It's only once we look back we can say, oh, well, hey, these dogs or these aren't the same species of dogs as these later dogs.
So, well, that's a long way of saying, I think you said, yes, you do believe at some point back in time it was a non-dog. Something that would not be considered a dog did give rise to something.
They are ultimately descended from non-dogs, correct.
Okay, and ultimately descended from a single-celled organism. Would you say that?
That's probably true.
Okay.
But I'm not saying it with any certainty.
Good, because you shouldn't. That's a religion, and you're welcome to believe that. But it's not science, and I object to having that taught to all the kids like it is part of science. That should be in a religion class at LSU, not in a science class. They're wasting classroom time to teach that as part of science. It should be in a world religions class. Now, I'm out of time here. Let me give you, you mentioned polyploidy, and so I called up a picture just real quick on Google of a polyploid strawberry, which is, I think, the example that I gave you before when we talked and before we agreed to record.
Right.
Polyploid means it has double, and some even have triple, the number of chromosomes. Okay, this happens. The polyploid fruit, in the case of the strawberry, is nearly double the size, or triple the size maybe. It has twice as many chromosomes. Now, and it's much bigger. Here are the problems with polyploid. A, it is taking a phenomenally complex genetic code and doubling it. It's an exact duplicate of the original code, so no new information is added. B, the offspring of these are nearly always sterile. Seedless watermelons might be an example, or seedless strawberries, if such a thing exists. Seedless grapes. Those are things that...
No. Polyploidy results is the reason for a lot of the food, the vegetables and fruits that we eat today.
Correct.
They're not sterile. They're used to grow more generations.
Correct. But is it beneficial for the strawberry to not have any seeds now?
Well, I mean, that's different from, a strawberry with seeds is different from polyploidy in general.
Well, are there any polyploid organisms or triploid? I'm looking at Google now. I just typed in polyploid.
Okay.
Are there any that would survive in nature without babysitting them, and that would then take over the population where all the strawberries are polyploid? And I can answer the question saying no. There are no examples of that.
I work for a mammologist, and so botany is really not my field, but I find it hard to believe that there are, but I find it hard to believe that there are no plants in nature that don't survive polyploidy without human interaction. Let's see if going to Wikipedia.
I'll tell you what.
Because, like I said,
why don't you? Hang on. Let's continue this conversation on another day, and you get really prepared and get some specific examples of any animal producing a different, not a story like it might have happened over billions of years. I mean a real example. Here's where we saw it happen.
Okay.
And I'd like to see that. Yeah, I apologize. I'm out of time. It's been an hour and a half. Sorry about that. But and this is kind of impromptu. But thank you so much for doing this, A. And you tell your university I would love to come. You get every professor from every discipline that you think applies here. And let's all go same time. I get half the time. And we discuss one topic at a time. And we can videotape it. And I can sell copies of the tape, and they can sell copies of the tape. No royalties to anybody else. All participants in the debate have 100% rights to use it as they see fit. Because I don't want to sell a video and have to remember to send somebody 30 cents. Okay.
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 I will consider that. Okay.
Yeah, please count me in on that. And if you keep studying, when you get to the top of the mountain of truth, you could be an independent Baptist, born-again Christian like me. Hey,
all right. I will consider that.
Please do. And if you get to Lenox, Alabama, please stop and visit. We are building a Christian camp here. Dinosaur Adventureland, and we can sit and hash all these things out and get it live on the camera side by side, and you can give me all your evidence for evolution. You're invited.
If you ever come to Baton Rouge, essentially the same applies. I don't have a park though, but I'll be in Baton Rouge.
Okay, well, I drove right through there 4 days ago, and okay, thank you so much, and I'm going to post these on Kent Hovind Official. You can tell folks to tune in, and then they can give you advice on how you would sharpen your arguments, and let's do this again sometime, okay?
Okay, thank you very much.
Thank you so much,
Jackson.
Nice, I got to go. All right, appreciate it. All right, bye-bye.
All right, goodbye.
All right, folks, that was an impromptu call. I had other things planned for the day, but an hour and a half nearly of discussion with this college student. I pray God will get a hold of him. Got to go. But if you have any questions on creation, evolution, give me a call, 855-BIG-DINO. If you're being taught this kind of stuff and it's harming your faith in God's Word, as it will, or causing you to doubt your faith, well, then you need to watch my video series, especially number 4. If I did not get, I don't have it here. I did not get Jackson's address or contact info, but I would, Jackson, if you watch this, I'll be glad to send you my seminar series free of charge. Call back on my number. We've already hung up, and I will send you my video series, and you can watch it for yourself. Thank you so much. I got to go. Bye.